Hello, my Calc 2 student. Today we talk about representation function by power series. This is section 9.9 and from your book. Before we started, I'm trying we need to remember what happened with geometric series. If you have geometric series, then this is up part is infinity, okay? Then you remember sum this series will be a over 1 minus r, whereas absolute value r less than 1. We try use this fact, and then we have, if you have power series x to the power n start with 0 to infinity, this will be, first term is 1, this means 1, over r is x, this means 1 minus x. And this series will be converges if absolute value x less than 1. Now, use this fact, we can rewrite some kind of function like power series. For example, example A. Let's go, our function fx is 4 over x plus 2. First, I need a little bit of work with this function because I need my denominator will be 1 minus variable part. Okay, what I can do it? I can write 4 over 2 minus negative x. Okay, I have this minus. What I need? Maybe I use different color when I show you what I need doing. I need minus, I did, but here I don't need 2, I need 1. How are we doing? Divide up and down part for your fraction for 2, and we have 4 over 2, it will be 2 over 1 minus negative x. And now we have some geometric series whose first term is 2 and whose r is negative x. This means here we have series twice. I'm divided by 2, this means negative x to the half power n, and start with 0 to infinity. Okay, it means here we have, rewrite little bit, negative 1 power n x to the power n over 2 to the power n minus 1, and start with 0 to infinity. Okay. Sorry. Okay, looking more example. What happened if I need power series with some given center? For example, B, we have function fx equal 1 over x, and I need to write is like power series with center 1. Okay. Prepare our function 1 over x, we need 1 over 1 plus x minus 1. I'm add 1 and subtract 1, this means nothing changing. Here I rewrite 1 over 1 minus, then I need plus x, this means I have minus x here. I need minus 1, this means I have plus 1 there. Okay. Now we have geometric series, and it will be series minus, where's come this minus? Tell me, please. Okay. Series is minus x plus 1 n power and start with 0 to infinity. I will write like -1 to the power n. Here I have x minus 1 to the power n, and with 0 to infinity. And we're solving our problem. Okay. Now we talk about operation with power series. Let's go, we have two functions which define like power series. One function fx, it will be a n x to the power n, 0 to infinity. And second function gx, we have coefficient bn x to the power n, and from 0 to infinity. Then, first, if I have power series for kx, f from kx, it will be power series and from 0 to infinity a n k to the power n x to the power n. Second, if I need f x to the some fixing power, well, let's go, it's big N, whereas big N is some constant, then for this kind of function I have power series is a n x to the power big N multiplied by small n, and from 0, small n from 0 to infinity. And third one, if I'm add or subtract these two functions, it will be a n plus or minus bn x to the power n, and from 0 to infinity. Okay. Doing some examples. Okay. Oh, just a moment. Oh. Example. Question C, because I'm used AB, then now C. Found power series for function f(x) equal natural logarithm x with center c equal 1. Okay. We remember derivative of our function fx will be 1 over x. And we remember we have, I think it's example B, what is series for 1 over x with center 1 is versus -1 to the power n x minus 1 to the power n, and from 0 to infinity. Take it integral for both sides. We have natural logarithm x will be integral from series -1 power n x minus 1 power n dx is equal 1 power n x minus 1 n plus 1 power over n plus 1, and still from 0 to infinity, and plus some constant c. But how we can find this constant c? How you remember, natural logarithm 1 is 0. But what happened if you plug in 1 in your series? You have 1 minus 1 is 0. This means all term is 0 plus c. This means c equal 0, and our natural logarithm x function we can write like power series with center 1 x minus 1 n plus 1 power over n plus 1, and start with 0 to infinity. Okay. Second example, next example, Z. What happened if your function is equal arctangent x? Gx equal arctan x. Well, first remember the derivative. Derivative g prime x, it will be 1 over 1 plus x squared. Okay, great. This means if I'm build power series for function 1 plus 1 over 1 plus x, I can use for g prime and then use for g. Okay, doing. Here we need rewrite our function, and it will be like 1 over 1 minus negative x, or it will be series negative x to the power n, 0 to infinity, or we can take it this minus. It will be negative 1 to the power n, x to the power n, and from 0 to infinity. Okay, what will be, how we can use g prime from x? It will be, because it's same like f from x squared, and this is will be use property of series. We have negative 1 to the power n, x to the power 2 times n. This means 2n. Great. And what will be gx? It will be integral from g prime x dx, or integral from negative 1. Oops, I forgot sigma, and from 0 to infinity, x to the power 2n dx will be, oops, okay, it will be series, and from 0 to infinity, negative 1 to the power n, x to the power 2n plus 1 over 2n plus 1. Because we integrate, we don't forget about c. Now we try found our c. Remember, the g from x, g from 0, it will be arctan. From 0, it will be 0. But if you plug in all element, your series is 0. This means 0 plus c. c equals 0. Okay? And now we prove arctan x is n from 0 to infinity minus 1 to the power n, x to the 2n plus 1 power over 2n plus 1 power. Okay, great. Now solving couple of examples from your book. It's help you found solving homework. Okay, number 12. Your function if fx is 4 over 3x plus 2, and they ask us write this function like power function and found interval convergence. Okay. Prepare our function. What we have? 4 over 3x plus 2. Here is question, sorry, center equal 3. Okay, this means first I'm doing 4, then 3x minus 3. Great, but it's mean I'm subtract 9. Okay, this means I need add 9, and I have plus 2 here. Continue. What we have? 4 over 11 plus 3 times x minus 3. What problem we have here? We have two problems. We have plus here, and we have 11 there. Okay, 11 we need 1. This means I'm divide up and down for 11. I have 4 over 11. Here I have 1 minus, and here I have 3x minus 3 minus over 11. Don't forget about minus in the inside parentheses. Okay, now my function is ready for writing like series, because what we have here, series, and from 0 to infinity, numerical got like coefficient 4 over 11 because it's first term, and r it will be what we have inside. This means minus 3 times x minus 3 over 11 power n. Continue, and we have series, and from 0 to infinity, here we have minus 1 to the power n, 3 to the power n, x minus 3 to the power n, and then times 4 over 11 power n plus 1. Okay. What about interval convergency? Remember, what is r for our geometric series here is 3, absolute value r. It's 3 x minus 3 over 11 absolute value. It need be less than 1. This means 3x minus 9 stay between negative 11 and positive 11. Add 9, you have negative 2, 3x and 20. Divide by 3, you have x between negative 2/3 and 20/3. Here we don't need check endpoints because this is, we talk about geometric series, and we don't need any integration on differentiation. Don't plug endpoint for this situation. Save time. This means minus 2/3, 20 over 3, interval convergency, open interval. Okay, next question is question number 14. Here you have function equal 3x minus 8 over 3x squared plus 5x minus 2. Same question. Write like power series and found interval convergence. We can factor in our denominator, and we have 3x minus 8 over 3x minus 1 and x plus 2. Use technique what we use for found partial fraction. We have a over 3x minus 1 plus b over x plus 2 multiplied by x plus 2. This is 3x minus 1. Coefficient x will be a plus 3b. It need be equal 3. Coefficient constant, it will be 2a minus b and equal negative 8. Okay. Easy way, I think, is multiplied by 3 and add. Then I have 6, 7, 8, no b equal negative 24 plus 3, it's negative 21. This means a equal negative 3 and 3b equal 6, b equal 2. Okay, this means my function fx is now negative 3 over 3x minus 1 plus 2 over x plus 2. Well, I think we first fraction is prepare and minus move to denominator. We have 3 over 1 minus 3x is great. And second fraction we have 1 over 1 minus negative x half. I'm divide up and down for 2, and because I need minus, it will be there. Okay, this means my first series for first fraction will be 3 times 3x to the power n, and from 0 to infinity. And my second fraction will be plus minus x over 2 power n, and will be 0 to infinity. Okay, continue. We have first series will be 3 power n plus 1 x to the power n, and from 0 to infinity. Second series give us negative 1 power n over 2 power n x to the power n, and it will be 3 power n plus 1 plus minus 1 n over 2 to the power n x to the power n, and from 0 to infinity. We did. What about interval convergence? First series is converged if 3x absolute value less than 1. Second series is converged if absolute value minus x half less than 1. Here you have x greater than negative 1/3 and less than 1/3. Here we have x greater than negative 2 and less than 2. Whereas both of these series is converges, whereas intersection to these two interval. It's happened if x between negative 1/3 and 1/3. Will be interval convergence. Okay. One more example. Number 24. Here you have function if natural logarithm x squared plus 1. And this function you need to write like power series. Like power series, that's it. And because it's a natural log, I think we take it first derivative this function. And it will be 2x over 1 plus x squared. I think I do it this way. 2x multiplied by series function 1 minus negative x squared, and it will be 2x multiplied by series with negative x squared power n, and from 0 to infinity it gives me negative 1 power n, 2 and 2n plus 1, it will be x power 2n plus 1, and from 0 to infinity. This is derivative of my function. This means function series for function is will be integral. Okay, fx, it will be integral from series and from 0 to infinity, negative 1 power n to x to n plus 1 dx. Continue. We have series minus 1 power n to x to n plus 2 over 2n plus 2, and from 0 to infinity, and plus c. Okay. Plugging x equals 0, f from 0, it will be exactly natural log 1, who is 0. If you plug in for your series part, you have 0 plus c. This means c equals 0. Okay. This means we proving this fact. Natural log x squared plus 1, it will be series minus 1 power n twice x to the power 2n plus 2 over, I think we can simplify here, and we don't need, we don't need 2 here, and our denominator will be n plus 1. I think it's better. Okay, great. What about interval convergence? Our derivative function interval convergence was, whereas x squared less than 1, this means x between negative 1 and 1. But because we found antiderivative, here we need checking endpoint. What happened if x equal negative 1? Here we can check in same time x equal negative 1 and x equal 1, because power x is even number is give us same result. Oh, here I not right, sorry, and with 0 to infinity. Okay, and give for both situation we have series minus 1 power n over n plus 1, and from 0 to infinity. This is exactly alternating harmonic series converges, and for our function interval convergence negative 1 1 include, endpoint include. Okay, and last example for this section is will be build power function for function fx equal x 1 plus x over 1 minus x to the square. Okay. First, what we have here? First, we have numerical maximum power is 2 and denominator maximum power is 2. I think we need to write one of the other. What we have here, we have x squared plus x. We will be divided by x squared minus 2x plus 1. And it will be 1 x squared minus 2x plus 1, subtract, you have 3x minus 1. Okay, this means my function fx is will be 1 plus 3x minus 1 over 1 minus x to the square. Great. Now, I'm try simplify something here. I write this way. It will be 1 plus, let's go, I have 3 times x minus 1. This means I'm subtract 1. I'm subtract 3. This means I need add 3. And 1 minus x squared or x minus 1 squared is will be absolutely same. Okay. Separate for two fractions. I have 1 plus 3 times x minus 1 over x minus 1 square plus 2 over x minus 1 square. Simplify a little bit my second term. We have this one. Okay, great. What we have about this fraction? 3 over x minus 1. It's exactly minus 3 over 1 minus x. And this one is will be, series is negative 3x to the power n, and from 0 to infinity. Great. But what is the relationship 1 over x minus 1 and 1 over x minus 1 square? If we take it 1 x minus 1 derivative, it will be minus 1 times x minus 1 square. This means minus 1 over x minus 1 square. Okay? This means if we want to take minus 1 over x minus 1 square, it will be derivative my series minus 3x to the power n. Take a derivative, it will be here is n from 0 to infinity. It will be series minus 3 to the n x to the n minus 1 and start with 1 to infinity. Great. And now we almost did, because what, remember one more time, what is your function fx? Is 1 minus 3 over 1 minus x, okay, and plus 2 over x minus 1 square or 1 minus x square is no big deal. Okay. And now we have 1 is 1. This series we write is minus 3 or 1 over it will be plus series minus 3x to the n, and from 0 to infinity. And second series will be derivative but opposite sign. This means here we have plus twice series 3n x to the power n minus 1 and start with 1 to infinity. Okay. What we can write is will be oh my god, we need combine together. What this will be for n equals 0, it will be negative 3, 1 minus 3 plus series and start with 1 to infinity minus 3x to the power n. Here I have plus plus 2 move inside, it means will be 6 and x to the power and from 1 to infinity. I need to write something. It will be this way. For example, oh, sorry, I don't need to take it first term. I'm doing something more complicated. I'm right. Just a moment. It's my mistake. I try clear here. It's the last question and I'm a little bit tired. Okay. What I'm doing here, I write 1 plus, at this series I write minus 3 x to the power n minus 1, but n start with 1 to infinity. You see, if you're checking all terms, this will be same terms. N plus 6 n x n minus 1 n to the 1 to infinity. And now we can rewrite like 1 plus series n start with 1 to infinity. Here it will be 6n minus 3 x to the power n minus 1. Finally, we did. What about convergence in this series? Okay, this is question. First series this will be convergence. First series what we start building is will be converges for x, absolute value x less than 1. Okay, x between -1 and 1, and then because we take a derivative is nothing better. This means this is interval convergence. It's it about this section.